What's going on, you guys? Mr. Allen here. We're going to be graphing a couple cubic polynomials in this video, but it might not look like it right off the bat because we have a couple interesting ones here. Now, both of these problems are very similar, but are worded very different. So check this out. First one, given f of x equals x minus 3 and g of x equals x squared, graph p of x equals f of x times g of x. So the product of the two functions. Well, I find it helpful just to write this out in factored form right off the bat. So I've got p of x, and when it's multiplication, I can really write these in either order. I'm going to take that g of x function, and I'm going to put the x squared first, and then I'll put the f of x second. That looks better to me than throwing the x squared at the end. It doesn't really matter. I just like x squared at the first one, and then any of my binomials thereafter, okay? Just personal preference, so that's what I'm going to do. Now, how do we graph these polynomials? Well, x-intercepts are key here, right? I got to have x-intercepts and a y-intercept, and then I can, get to work. Well, x squared. What's my x-intercept for x squared? Well, what's going to make x squared equal 0? It's 0. So if I'm putting my x-intercepts together, my little list here, x-intercepts, 0, 0. And then what makes this factor right here 0? Well, 3 minus 3 would be 0, so 3, 0 would be my x-intercept. How about my y-intercept? Because that's another good point to have on any graph. If it has a y-intercept, we should probably plot that. It's a key point. Isn't that also my y-intercept? Because if x equals 0, then I'm crossing the y-axis. If y equals 0, then I'm crossing the x-axis. So I get the respective intercepts. So anytime you have 0, 0 for an x-intercept, it's also going to be my y-intercept. So let's plot those two. Then we got 3, 0, 1, 2, 3. Boom. Now, many teachers may ask you to, get another point on here if you're passing through the origin and we don't have our y-intercept isn't a unique point from one of our x-intercepts. It's a shared thing. So let's do one more point. I'm going to pick, how about positive 1? I feel like that's a pretty easy one to plug in. So I'll do that in a different color here. If I want to get 1, something, well, what is that something? Well, I can plug in 1 here. So I'll do that. I'll have 1 squared. So p of 1 equals 1 squared. And then we have 1 minus 3. So it's a little jumbled there. Well, 1 squared is just 1. 1 minus 3 is negative 2. So if I multiply those together, 1 times negative 2 is negative 2. Yay! So that would mean I am down here. I'm actually going to scale this one out. 1, 2. You don't have to. I could have labeled the ordered pair here. I could have said, oh, this is 0, negative 2. Wonderful. I could scale it out. It's up to you. Usually we leave these y-axes unscaled because sometimes the y-intercept gets out of hand. It's like negative 137. It can be kind of crazy. So anyways, there we go. All right. Now, is this a positive or a negative cubic function? Well, if this is positive x squared and this is a positive x here, so if I multiply it out, it's going to be a positive cubic function, which looks like this. And I always like to do like a practice graph off to the side, right? Not actually, I wouldn't put it on your graph. I just don't have a ton of room here. So I like to do a practice positive cubic function and think, okay, how is this all going to look? Well, the x squared, what's the significance of that one right there? This is actually a multiplicity. This x-intercept is a multiplicity of 2, meaning it's going to bounce. Well, where can it bounce off of a graph like this? It can bounce off of the local maximum or the local minimum. And when I say bounce, I mean it's going to be like, boom. It's just going to pop off that or go bounce back up off of it. It's going to be tangent to the x-axis. So if I'm bouncing off of the first one here, where is it going to bounce here? It's going to be bouncing off the local maximum, the first high or low point. If it were bouncing off of this one, then I'd be bouncing off of my local minimum. It'd be the second spot. So now I know my x-axis is going to look like that, and my y-axis is actually going through that point. So I've got a general idea of how this graph should look. Now that I did a little rough sketch off to the side, let's do the real thing now. Right now that we've rehearsed, we've practiced, we've done a run through, right? I can be like, boom. Okay, and this is not a minimum, right? It's not a low point necessarily. So I'm just going to pop up, pass through it, and back up to this guy. Woo! All right. There we go. Make sure you're not flaring out, right? It's just coming down. It's actually getting more vertical, right? It's never getting totally vertical. It's just getting steeper and steeper. I've got arrows on there. I don't come back up. This is a little squiggly here, but not too bad. I don't come back up and over, right? I don't go past this guy. I'm like, whoa, I went too far. And I can do this whole weird thing because then it doesn't pass the vertical line test. Okay, so it's got to pass the vertical line test, thus it's a function. Make sure that you have the proper, for this guy, it is going up and to the right because it's a positive cubic function. Okay, so there we go. We're graphed. We're ready to rock and roll. Now, how about this one? And I did say that they are similar, but they look like they're worded very differently. But we can approach them in a similar way. Check this out. It says if f of x equals x minus 4 times x plus 1 is multiplied or dilated. Some people will use the word dilated, like in geometry, like multiplying. I prefer multiplied, but some texts use dilated by 3x. The resulting function is p of x, graph p of x. Well, how about we also write it in factored form? So we'll say p of x equals 3x times x minus 4 times x plus 1. All right, so that is my factored form there. And I find that helpful to finding our x-intercepts, right? Now I've just made this problem into the same one that I just did over here. Let's find our x-intercepts. Well, this one's going to give me, let's see your x-intercept. This is going to give me 0, 0. This one's going to give me, let's see here, what makes this 0? 4 minus 4 is 0, so 4, 0. Here, it'd be negative 1, comma 0. Whoop, don't forget my parentheses. And we've got our 3 x-intercepts. 0, 0, 4, 0, negative 1, 0. Lovely. All right. This is a positive cubic function, so it'll be kind of similar to that one. The bounce is going to look, there's no bounce on this one because there's no multiplicity of 2. But once again, my y-intercept is also going to be the x-intercept of 0, 0, right? That's a shared one there. If it passes through the origin, you're going to need that. Now, again, oftentimes some teachers will require another point if it passes through the origin because you don't have like a unique y-intercept from its x-intercept, right? They're shared. So let's just pick it up. Let's just do 1 again, right? Let's just do 1. It'll also help you figure out how this graph looks if you plug in that extra point if your teacher requires it. I don't always require it, but hey, why not? So let's plug it in. We'll do p of 1. Okay, so p of 1, that's going to be 3 times 1, so 3. And then I have 1 minus 4, that's negative 3, right? And then 1 plus 1 is 2 last time I checked. So we have 3 times negative 3, that's negative 9 times 2 is negative 18. So we have 1 comma negative 18. That's an ordered pair. Shoop, boom. Put that right there. I'm just gonna label that one 1 comma negative 18 because I don't feel like going 18 times. My marker is not that fine of a tip there, and we are about ready to rock and roll. But I will do a little rough sketch here. This is a positive 3x, positive x, positive x. It's going to be a positive cubic function. And we don't have any bouncing, so the x-axis is just going to pass right through all 3 of those. And where is my y-axis at? It's at the middle x-intercept because it is going through 0, 0. So there's my axes, right? Now I kind of have a general idea of how I want to graph this thing by placing everything. Right? It's passing through the origin. That is the middle point. So boom, I went through the middle x-intercept on that rough sketch graph. Now we can just be like, shoo, shoo, shoo. And it's good to do that with the sound effects. Maybe not the sound effects on your test, but to be like, okay, I'm going to do this. I'm going to pass through this guy and come down a little bit and then back up. Right? Because this guy's pretty far close to this one, and this guy's a little bit further over. So I feel like I need to pass through it and then come back up. Because if I just do this and go right to it, I'm gonna really be oblonged on this side, right? Where I'm being pretty steep here. So you kind of want to have the same slopes to them, right? It's not a slope because it's ever changing, but have the same kind of curvature to them. Okay. So I'm gonna start by going up. I'm gonna pass through this guy, and then make my way up. Beautiful. Lovely. You don't want to go too far and be like, oh my God, I got to come back, right? As we said, it's got to pass the vertical line test. I pop some arrows on it. You don't have to go too high up here. But again, plan your attack. Light sketch, maybe with pencil, and be like, okay, I like that one. Let's make it a little darker. Final answer. Wonderful. Okay. Graphing polynomials can be kind of tricky to make them look right. It takes a little bit of time. When you do graphing, you're like, that looks good, man. That looks good. That's beautiful. Okay. I think that's about it, guys. That's fantastic. You know what? One actual bonus. Let's do a quick bonus. You guys got time for a little quick bonus? Quick bonus? Okay. Let's put, just in case, because I might be feeling spicy on a test, okay? And I might say, write this bad boy in standard form. How do we write it in standard form? Well, I'll show you. So I have P of x equals 3x times x minus 4 times x plus 1. Okay? I feel like we got just enough room to make this happen. If I'm going to put this into standard form, that means I'm going to multiply it all together. I'm going to deal with these two first, okay? So I'm going to have P of x. I'm not even going to touch that 3x. I'm going to multiply x times x, that's x squared. X times 1, that's positive x. Negative 4 times x is negative 4x. And then negative 4 times 1 is negative 4. Okay? So I'm foiling it out, or distributing is the better math term. Foiling, that's more like street math term, right? It's not real proper. Some people are like, don't say that, right? First, outer, inner, last. It helps, okay? But distribution's the actual math word, and distribution would work for anything being multiplied together, a binomial times a trinomial, or whatever. All right? I got to clean this up. So I got P of x equals 3x times, then we have x squared. That doesn't change. 1x, negative 4x is negative 3x, negative 4. What did I just do that for? Oh my goodness. Now I'm ready for my parenthesis. Okay. And lastly, we are going to distribute this 3x into all these. So I like to multiply the two binomials first and then distribute that 3x in. Let's see if we can get this to look okay. I'm going to put my final answer in blue here. We're going to have P of x equals 3x times x squared is 3x cubed. 3x times negative 3x is minus 9x. And then 3x times negative 4 is minus 12x. Boom. There it is. I'm not even going to circle it. This is getting too messy on there. But there we go. We have it in beautiful. Did I miss anything here? I missed an X. Boom. Now we got it. Woo. Caught my own mistake. That's a rarity, guys. Sometimes you forget that. I was like, that doesn't look right. And again, I forgot to write my squared. Oh my goodness. Mr. Allen, you're all over the place. Okay, so I distributed the 3x to the x squared. Let's double check it. We get 3x cubed. 3x times negative 3x is negative 9x squared. 3x times negative 4 is negative 12x. Just dropping degrees all over the place, man. Well, you know, fall is coming here. The temperature is going down. Degrees are dropping. Get it? Get it? No. It's a bad joke because I should have not made that mistake. But anyways, double check their work. So that's how you get into standard form. You multiply it out. But usually factored form is just ideal for these. Sometimes we ask that on a test, though. Put it into standard form. So that's a ton of math there, guys. That's a lot going on there. Thanks for watching if you watched all the way to the end. And, if you have any questions, pop them in the comments. And have a great day.